Hello everyone, this is Anand Ranjan, Assistant Professor, School of Computer Application, Babu Banarsidas University, Lucknow. Welcome you all in the video lecture series of digital electronics. In this video, we will discuss the switching circuit. Hello and welcome you all in the digital electronics video lecture series. I Anand Ranjan, welcome you all, and today we are going to discuss the concept of switching circuit. We are going to discuss today switching switching circuit. Okay, this is again a very interesting topic in context to digital electronics, where we are going to learn about how to means physically verify these logic gates and its operations. Okay, so for understanding we will start with the buffer operation, and for that let me draw one diagram to explain the buffer operation with the help of one switch and bulb. Okay, so here we are going to draw this diagram. This is key, one key, and let's say A is a switch, and this switch in series connected with a bulb. Okay, let me draw in the bulb in this manner. This is, let me take symbolically, this represent a bulb, and this bulb along with in series with this switch is connected to a supply V volt. Okay, and here we take the operation, here we take the function f, which indicates the glow of this bulb. If it is glow, then this function represents 1, and if it is not glow, then it is represented as 0. So for the glow of this bulb and its operation reflected by the function f will be depend upon the switch A, whether the switch A is open or whether a switch A is closed. And of course, when the supply is connected across this bulb by using this, when the switch is closed, then this bulb will glow, and when the switch is open, then this is not glow. So let me take this entire operation in one small table. Let me take A value and the input, A as a input and F as a output function to represent it. So for example, when switch A is open, then we can say A is 0. In that case, there is no current passing through this bulb, and hence this bulb is not going to glow. So we can write this F value is also 0. Similarly, if A, when we done a close, then this close connection will be represented by A, and when the switch A is closed, then a current is passed through this bulb, and of course this bulb is glow, and this will be represented by the output function 1. And of course this entire switch and glow operation is equivalent to the buffer operation. This is the buffer operation. When switch is on, output is there. When switch is off, output is not. Okay, now let us see the another aspect of this, because besides connecting this switch in series with this bulb, let me take this switch connected across this bulb in parallel. Then let's see what happens. All right. So now instead of connecting switch in series, just we, in the above case, in this diagram, we connect the switch in parallel. So what happened if we take switch connection A open and close basis? If for example, if it is open, then we will treat it as A is equal to 0, and if it A is closed, then we will treat as A is 1. So let me take this inputs from the switch and record the output accordingly, depend upon whether the bulb is glow or not, by positioning the switch A open in open and closed position. So for example, initially if we have open switch, if the switch is open, then what happens, there is no connection here. These two terminals are open, and the voltage which is supplied here will directly appear across this bulb, and of course with this voltage there will be a current flow with this path, and in that case you will have the bulb glow. Okay, and in that case you can write, when the switch is open, then the bulb is on, and hence you can write the output function as 1. And what happened when this switch A is closed? When the switch A is getting closed, then of course with the supply is connected across both the terminal, this terminal to this as well as this terminal to this in parallel. But as we know, the tendency of current is to follow the easiest and low resistance path. So in that case, the current in the second case, when the switch A is closed, let me write the switch A closed condition A is equal to 1. Then what happened, for the conduction of this path is the easiest path, and no current will go through this bulb path. Okay, so in that case the bulb will not glow, and the entire current will follow this path. And of course the function f reflects only the position of bulb glow. So what we can write here, that when the switch A is closed, then the output function f will be 0. And interestingly, this operation is equivalent to your NOT operation. Okay, because you are supplying 0, you will get 1. If you are supplying 1, then you will get 0. Okay, so this is your equivalent to NOT operation, or this can also be known as the inverter operation. Inverter operation. Okay. Now let us see more Boolean expression and its logical explanation using the switching circuit. Moving towards the AND operation, let me first draw one diagram in which I am considering two switches connected in series, and with a bulb like this, and this is connected to a supply, plus minus you can say supply V volt. Okay, and this is let's say this is switch A, and this is switch B, and this is your bulb. This is bulb, and the glow of bulb will be represented by the function f. If bulb glows, then it will be 1, and if bulb not glows, then it will be 0. And of course the glow of bulb will be depend upon the position of A and B. So for for the operational point of view, let me draw one table, because this time we have two switches, and with these two switches we can able to produce four different combination, whether the both, and these four different combinations are whether the both the switches are off, both the switches are on, or alternatively one on and one off. Okay, so all these possibilities of operation of the switches on and off behavior, let me draw one table in which we can capture the all operations. Okay? Or you can say this is the overall operational table of this circuit. Okay, So let us first, make both the switches are open. So both the switches are open means there is A is equal to 0, B is equal to 0, and of course when both the switches are on, there will be no path to directly connect this voltage across this terminal so that the current will flow and bulb will glow. So in this case what happened, that there is no current in this bulb and the bulb will not glow, and when the bulb is not glow we can write the function f is equal to 0. What happened if we put a switch open, and if we close this switch B, then closing of this switch B represented by 1, then of course there will be a one hurdle will be available to flow the current from this path by making this A close, sorry, this B is closed, but there is a open circuit which not able to flow the current through this bulb. So in that case, if A is open, then it will not allow to pass the current for the further circuit so that the bulb will glow, and in this case again you will have 0. The third combination, if A is closed and B is open, then what happened, again you will not able to have path for current conduction across this bulb to glow it properly. So you will again say that when A is closed, B is open, you will not have a proper path for current, so bulb will not glow. So this is again 0. And lastly, when both the switches are closed, then of course there will be a path for the current conduction across this bulb and bulb will glow. So when both the switches are actually closed, then the output bulb will glow. Okay, so this is the entire operational conditions, you can say, of this specific circuit. And of course this operation table, this operational data is actually nothing but the AND operation. This represents the AND operation. Okay, this is equivalent to the AND operation. And as we have already seen this case of AND operation, that your output is high if and only if both the inputs are high, otherwise it's getting low. Okay, so this is the explanation of switching circuit equivalent, switch circuit equivalent of the AND operation. Okay. Now, besides connecting these two series connection, you see two series switches in series with this bulb. This what happened if we connect this entire branch consisting of a series switches, not in series, but what happened when we connect it in parallel. Let's see. This is switch A, this is switch B, and of course this is bulb. Here we are interested to know the glow of bulb, which is represented by the function f. Okay, so let me draw one table just like we have discussed in AND case, including all the position of switches. So again we are using here the uh, two different switches A and B, and with this two switches A and B we can able to manage four different combination of these switches operations, and these are both open, both closed, and alternative open and closed. So with this we can make a operational table of this diagram. And of course what you can observe here, when both the switches are open, means when both the switches are open, means A and B are both represent as 0, then what happened, of course there will be a path, direct path of this voltage will appear across this bulb and there will be a current flow this diagram. Then what happened, the no matter no matter the switches are both the switches are in open condition, then there will be a current in this bulb and of course the bulb will glow. So you can write it as 1 at the output. If the A is open and B is closed, then nothing change in the operational ability. Of course there will be no path in for the current in this branch. The entire current will be flowed across this bulb and of course this bulb will glow. In the third case again, we will have a condition where we put A closed and B open. In this case again there will be no path for conduction of the current in this case, in this branch, and entire current will be flowed this across the bulb and of course this bulb will glow. But what happened when the both switch A and B get closed? Okay, interestingly, you see both the switches are closed, then of course the voltage across this branch connected which is in parallel to this bulb, and of course this we are considering the this branch in which the AB are connected in series will exhibit the low resistance part, then entire current will follow this path. There will be no current in this branch. In that case, when both the switches are closed, there will be no current flow across the bulb and bulb will not glow. So we will mark this as 0. And if you closely observe the operational table of this circuit, and this is nothing but equivalent to your not AND operation or inverted AND operation, or more specifically you can say this is equivalent to your NAND, not AND, NAND gate operation. Okay, so this is equivalent to NAND gate operation. Now let us discuss more gate and its equivalent circuitry, switching circuitry uh, with this diagram. Let's move on to the next arrangement of switches and bulbs, and this time we will take two switches connected in parallel, and there is a bulb, a supply connected here. This is your bulb, this is function F, and here we have switch A, switch A and B. Okay, okay, with this arrangement, let's again we are using two switches, and these two switches can be operated in four different phases, and these are both open, both closed, or alternative open. So this can be written as, let me write all the combinations, or better to take one by one and we will draw the entire. Okay. So what happens when both the switches are open, then of course there will be a no path for the current to flow across this bulb, and hence the bulb will glow. So no path will for the current conduction, and the bulb will not glow. So we will write it as 0. What happened when the A is open and B is closed? When A is open, there is no path for the current in this way. But yes, when B is closed, we have a path for the current conduction, and this current will flow through this bulb, and in this case the bulb will glow. So in this case you can write F as 1. Thirdly, if A is closed and B is open, then of course the path, in this case also we have one path by for the current, in which this time the current will follow this path and it will glow the bulb. Okay, so in that case we can write function F is 1. And when both A and B are closed, then of course both the branches having the equal potential, then both the current cannot the current will be flow either of the path. Okay, So in that case, the bulb is also glow, because for the glowing of bulb will depend upon the current which is coming from the source of, this path. Okay, so if you observe this operation table, then you can see that this table is nothing but the truth table of your OR gate, which is equivalent to your OR gate truth table, where you can have the condition that any of the input is high, then the output is high. Okay, now interestingly, let us take this entire branch of parallel connection of switch connected across this bulb, not in series but in shunt. Then what happens? Okay, this is voltage B, switch A and switch B. This is bulb, and we are interested to know the output function F, which represents the glow of bulb. Okay, so similar to above discussions with these switch positions, we can have four operation combination. Let me write it as A, B and F again, and record for which condition the bulb is glow or not. So one by one, when both the switches are open, then what happened? Of course, there will be no short or low resistance path at either of these two branches. Entire current will flow this branch, and of course, in this case, your output is your output is 1, because bulb will glow. Okay, because bulb will glow, no current flow either of these branch, either this, because both are open. And in that case, the voltage is directly connected to bulb, the current will flow, and that will able to bulb glow, and that bulb glow will be reflected by F is equal to 1. But what happened when you will, close one switch? Let me take first B is closed. Then what happened? This by closing this switch B, you have an alternative path for the current, which is the low resistance path. In that case, no current will flow across this bulb, so the bulb will not glow. In that case, the output function will be represented as 0. Thirdly, if you close A and open 0, then of course again you will create a low resistance path shunt across this bulb. The whole current will flow this path. No current will flow in this across this bulb. Then again the bulb will not glow. And what happened when both the switches are, on? Then of course, two alternative short low resistance paths are available for the conduction of current coming from this source, and no current will flow across this bulb. In that case also, the bulb will not glow, which will be reflected in this column F by 0 value. Okay, and if you observe the operational table of this circuit by this diagram, then you can recall that this is nothing but inverted NOR, you can say, or you can say this is the NOR operation. NOR operation. If any of the switches is on, then output is 0. Okay, so this is the concept of switching circuit. And of course, by considering the position of switches either in parallel or in series, okay, you can able to see the interesting results of the entire. Okay, but let us take few examples. Let's take one example. For example, one circuit is given to you, and you are supposed to write the function f for the conduction of, or for the glow of this bulb. Means you have to write the condition when this bulb will glow. Okay. So switches, let me write switches as this is A, this is B bar, this is B, this is C bar, and this is D. Okay. So just follow the previous convention. If somebody asks you, you have to write the function f, so that you know this bulb will glow. Then of course you will have two different arrangements, two parallel different arrangements. So that's why I am writing these two blocks here. F is if one will represent the logic condition for the bulb glow here, and another is represent the logic conditions over here. So the condition for the glow of this bulb, by following the previously discussed concept, will be given as that because here you can say that the A and B bar, these two switches are connected in parallel. So we will follow the previous condition. This is OR condition. So by ORing conditions, what you can write this will be logic for that, and this will be A plus B bar. And secondly, this is the series connection. For series, it will represent the AND connection. So and so we will write here this is A B C bar, and this AND is connected to D, so this is represent OR operation. We can write it as D here. Okay. So in this manner, this is the first type, you can say, to write the function f for the glow of this bulb. Another example, let's take another example in which let's say this is bulb, and let's take these switches are A, B bar, here B, C bar, and D bar. Okay. So you have to write the function for this, so that this bulb will glow. And of course, again, there are two shunt branches are here. So one logic will be given in this manner, and this time two shunt, because in the previous case, if you observe the previous case, we will have series. Then series is AND operations we are considering, and here you will have parallel, so we will use this OR operation. So this will be your OR term. Okay, this will be your OR term. Two OR term representing the two shunt branches logic for the conduction of this flow. And of course, the first shunt branch, if you assume these two switches are connected in series, so you will write here the first logic will be your A B bar, and second logic will be called as your this series means BC bar plus D bar, because it is in parallel, so this is D bar. Okay, this is D bar. So this is the logic to glow this bar. Okay. All right. So let us stop here and we will continue our discussion on on positive and negative logic in the next video. Thank you so much.